Thank you, Lauren. How are we doing on sound? Awesome. So thank you very much. Kind of the germ of this talk started about 3 or 4 years ago at a Condor Week. One of our commercial users said something, kind of an offhand comment that really struck with me and has been with me since. He said that his favorite part of Condor, his favorite aspect of Condor, wasn't that we can run a lot of jobs or that it's open source or that it doesn't have any bugs, but that under Condor, there's a strong sense of architecture. There's a strong sense of design that underlies all of what Condor is. And to the degree that you can sort of harmonize the way that you administer your Condor pool and the way you organize your job and your works in harmony with that philosophy, with that religion, if you will, you're a lot better off. But, he said, and this isn't all about good news, but he said, we do a terrible job of documenting and sharing and communicating this philosophy under it. So after I heard that, I sort of took it to heart, and I've been trying to give Condor Week presentations that aren't necessarily about how to use Condor directly or what the knobs do or what a submit file looks like, but kind of get at this underlying philosophy and try to do a better job of communicating to it, communicating it with the community. Not that you necessarily need to be an expert in this to really use Condor at all, but I think to the degree that our community, our administrators, our users, our facilitators understand that and work well with Condor, I think we're all better off. So this year's edition is about job wrappers. A lot of people hear that we don't like job wrappers and don't really understand why. So that's what this talk is all about, or maybe a better, do I have clicks here? There we go. Or maybe a better title would be how to reliably run jobs even on unreliable places, which is kind of all what we're about. So first I'm going to start with a very short discussion about what we mean by reliability, because that's not necessarily a common thing. We'll follow up by a quick review of how Condor runs jobs. And then we'll get into discussions with the meat of the talk will be problems with wrappers and how Condor runs jobs. And finally, we'll have some discussion about solutions, old and new, that will hopefully make our ability to run very reliably at scale in general. And you'll notice that occasionally there'll be a little red asterisk. Obviously, my slides, my discussion is simplified for the material. So if you see something that maybe is not quite 100% right, please don't raise your hand and say, oh, but you know, if you set this knob for obfuscate to false, then this doesn't always happen. Just sit on your hands and we'll take the questions later, Todd. So with that, let's start with reliability. And what do we mean by we want to run jobs reliably? Do we mean we will never have a problem at all? Do we mean that a machine will never crash or will never have a network failure or a disk failure, or like I think we heard earlier, some machine running slower than it should, or as Brian talked about, we land on a machine that has a dial-up network or a network that's as fast as a dial-up network? No, this is not what we mean at all. We don't live in a world where we have perfect machines or networks, but we can still run jobs reliably despite that. So why do we accept this? Well, you know, we have to. This is the world we live in. But I think more importantly and more fundamentally to Condor, to the degree that we can accept running on less than perfect machines, we get more machines that we can use and we can have more throughput. So as an example of this, a few years ago, LEGO figured out that they could buy very expensive compute-oriented GPUs, or for a lot less money, they could get a lot more gamer-oriented GPUs that occasionally crashed. But by being able to detect those crashes and rerun jobs when it had crashed, they were able to get a lot more science done for a lot less money. So that's kind of our goal here, is that we want to be able to tolerate poor machines or poor failures or poor software and get as much throughput done as possible. So for us, reliability doesn't mean we only run on perfect machines that run in perfectly maintained data centers with the high priesthood of system administration tending to them and administering through every need. We run on real machines that are all over the place, that are maybe hand-me-downs or not necessarily our first choice. And to do this, Rob, means first that we can detect errors. You know, if we can't detect the error at all, we're in really bad shape. But even once we detect that, we need to classify. We need to know what kind of error this is. Is this an error that maybe is transient and we could retry? Is this fundamental? Is this what's going on here? So we really need to get our arms around what's going on. And even once we have this, we need to report this error. So a lot of times, the place that can make a decision about the error is far away from the locus of the error itself. In particular, in Condor, the term that you've probably heard a lot today, the access point in a lot of cases really needs to be the place where we make a decision about what to do once we get this error. So we need to get this information back to the AP. And finally, then and only then can we respond to errors. And how we're going to respond to errors is way beyond the scope of this talk. You can imagine all kinds of different ways we could respond to an error. We could retry a job. We could retry a job, but maybe on a different machine. We could retry a job, but maybe on a different site. Maybe next year we'll know what a site is. And we could retry all job, or we could not run this job at that site. We could say there's 10,000 other jobs that are kind of like this job, and we're going to preemptively not run those jobs on this site either. So that's all I'm going to talk about, how we're going to respond to these errors. But you can imagine that there's all kinds of different ways. But none of them work if we don't get that classified error back to the AP. And that's really what I want to talk about for the rest of this talk. So how does Condor run jobs? Hopefully this is review for all of us. So again, you'll see the little red asterisk here, Todd. Sit in your hands. This is a simplification. Very good. When Condor starter actually gets the job on the execution point, it'll make a scratch directory and it'll start the program that's named in the executable line in the submit file. And I think as users, as administrators, something we kind of forget about a lot is that we love our programs and we know exactly what they do. And we have a really good idea in our head that our program, maybe it's a fast Fourier transform. We know all the steps it takes and what its likely failures are and how long it's supposed to run and maybe how much memory it's supposed to use, or maybe it's a genetic search, or maybe it's the EHT search. But that's not how Condor sees your program. Condor really doesn't know that much about your program and what's going on. When Condor runs your program, it kind of just sees it as an opaque box. It doesn't know what's going on. It doesn't really know what it should be doing. Now, there's a few things it knows. It knows the memory usage and the CPU and GPU usage. And most importantly, for the context of reliability, it knows the exit code of the main process in the job, and it sends this back to the AP. And this exit code is really critical in a lot of cases to detecting errors. So let's talk about exit codes real quick. An exit code is about 8 bits of information that a program can return to its parent at exit time. And right now, it's pretty much the only way the program can communicate how it did back to the starter and then to the AP. And by convention, only by convention, 0 means good and everything else is bad, but that's just a convention. I'd ask a trivia question, which I can ask because Carl's not in the room. What's the exit code for the grep program? Anyone know? It depends on the command line option. See, we have an expert in the room because the answer is always it depends. But sometimes the exit code of grep means it found something or not, which is clearly not an error, right? Well, maybe it is, right? So it depends. So because of this, Condor can't really assume anything about exit codes. Even though we have this convention that 0 is good and everything else is bad, if we held every job that exited with non-0, we would be in a bad state if we report an error. So this is kind of a problem we have. As an aside, DAGman has more options because it has a submit file and it can resubmit and it can do a few more things. But in general, we can't really assume that much about exit codes. So exit codes alone are not a complete way for Condor to understand the entire set of possible errors that could happen with your job. So that brings us to wrapper scripts. So what's all this about shell scripts? Well, continuing with our theme about exit codes, the xcode of a script is either the argument to the exit built in or the exit code of the last command that the script ran. So finally, we get to this evil wrapper script example here. And this might be a typical kind of wrapper script example. We have the actual executable, that's my job, in the middle, and we do some setup before it and some cleanup after it. So if I run this today, what's the exit code? Does anyone know? That's right. You think that's the exit code we want? No, probably not. So at first, maybe this seems like it's easy to fix. We'll capture the exit code here and saved exit, and we'll exit with that exit code. So we'll actually return the bona fide exit code of the executable back to Condor, and then it's the AP. But this is really tedious in the real world because, well, what if there's a failure here? And more importantly, we need to understand what kind of error happens up here. Is this setup error really the same as a job error, or is it environment error? Is it something that we could maybe fix by rerunning, or is it a site-specific thing? So we really need to understand the bigger picture. And in a lot of cases, these wrapper scripts have kind of the same, or parts of the wrapper scripts have the same sort of organization where you have some setup, and then you run the real executable, and then you do some cleanup. So we set up, we run, and then we clean up. And when I talk about wrapper scripts, they're not necessarily all 100% completely evil, but this idea of running your setup inside the job is really what we're trying to work around. Because remember how Condor sees the job? That's right, it's just an opaque box. Condor doesn't know that there's some setup going on in that opaque box. If it's a wrapper script, it doesn't know there's cleanups. It doesn't get happy, it doesn't get sad, it just runs programs. So the fundamental problem here is that Condor can't differentiate a setup problem or a cleanup problem that may be environmental, that maybe it could fix by the retry or restart or buying more machines from Amazon or Google Cloud or wherever. And we really want to be able to treat these kind of problems differently. We want to treat an environment problem very differently from a problem in the job. Maybe my genetic search returned an error because it couldn't find what it was looking for. And that's a really different kind of error from I failed to transfer my input files. And we want to be able to treat those differently. And really that is to say that wrapper scripts like this hide activity from the batch system, and that error codes alone are not sufficient to communicate what's going on inside that opaque box. And I think more fundamentally, the error code, the domain of error codes from a job belongs to the job proper. If the job is a genetic search, it has a set of error codes that it defines that we need to not override or not redefine or not overload. But there's maybe a different set for grep or for a image reconstruction or whatever. Other errors, like a failure to transfer files, or maybe the network goes down between the AP and the EP, those errors belong to the HTCondor domain. And we really want to be able to separate those two error domains. So finally, we get to the point where we want to talk about how to fix this problem and to run more reliably. So given that we have this setup where the EP runs the job by making the scratch directory starts the job, the proper fix is to separate this and take the setup and the cleanup and move it to places outside of the job proper and have Condor do the setup and the cleanup to the degree that it can. And when we run the job, we're just running the job itself. So any error code that comes back from the job is from the job proper. And any failures in the setup, Condor knows about directly because it was responsible for the setup, or failures in the teardown the same way. Condor did it, so it knows exactly what was going on. And we don't have to overload and merge that error code. And with my pointy-haired computer science hat on, this is actually a really common pattern in computer science. So if you're an OO person, object-oriented person, this is like having a constructor and destructor set up your object and tear it down. and get your object to a known good state or fail trying before you use the object. Or if you're a database person, this is like distributed two-phase commit, where you have a prepare transaction phase where everyone gets into a safe state before you try and commit an atomic transaction. So we want to copy this pattern into Condor, so we have a phase where we set everything up, we know it's good or not, and then we run the job. So what does this mean for users? This means that we need to translate some of this shell language into Condor language, usually into the submit language. And I will grant you, this is a bit of work. And if you want to run at the highest level of reliability, we need to invest some time. You can read the submit man pages for all the wonderful things that submit can do. I'm going to give you a few examples to follow because I'm getting the stink eye from Brian. So a very common thing that the setup might do might be set an environment variable. And on the left here, you might see the snippet of the wrapper file that does that, exports my variable equals hello. Well, Condor can do this itself. And there's a very straightforward translation. You could take that out of your wrapper file and put it into the submit language with the environment equal command. Now, something that we added in Rhine something was the ability to specify the Condor scratch directory as part of environment variable. And this was a common use of shell wrapper scripts that we were able to provide a Condor way to avoid with this magic $$ Condor scratch dir expansion. So again, this is one way that we can translate something that was in the shell language used for wrappers into Condor proper. Another very common thing we see are people untar their input files. Their input files is stored as a large tarball, and it needs to be untarred before we use it. Instead of doing that, we can transfer an expanded directory in the Condor transfer input files language with the slash behind it, as I think Christina showed us on Monday. Excuse me. And this will transfer the directory. And when the job starts, the directory will be expanded all the way. Does anyone want to guess what is faster? Transferring a compressed tarball and expanding it in the wrapper script, or transferring a whole expanded directory in the good-looking man in the gray shirt? It depends. That's not the correct answer. That's not the correct answer. The correct, yeah, the man behind him. That's not the correct answer. The correct answer is, in a lot of cases, not all cases, because it depends. It's more important to be reliable about this than to be fast. And with this, if the scratch disk fills up because we've got too much, we've transferred too much files, Condor will know in the right-hand side. If you're not checking the return code of tar, you could be in trouble. Now, it turns out that the transfer input files is actually usually a little bit faster, depending on your mileage. But I think it's important that we understand that the difference in speed isn't that much. And when it's not significant, it's not 10x, you know. But when it's not significant, we need to think more about correctness and reliability, especially in the face of these rare random problems like your disk fills up, or you've got the wrong version of tar, or the tar doesn't know how to, or you got a corrupted tarball, or all these things that you'll notice that in wrapper scripts that call tar, they never check for the failure of tar. And even if they did, it's difficult to know what to do. So the second example is similar. Common paradigm we see in these wrapper scripts is getting an input file from HTTP via wget or curl. And again, we can replace that with submit language by using the transfer input file mechanism. Maybe you're transferring a tarball. We can do HTTP plus tar to unexpand a tarball that we get on the fly, except this doesn't exist yet. So, but it should. And if you're with us on this, the architecture, you should shame us about not having that. But as Kay Scott from NRAO showed on Tuesday, the nice thing about these transfer input files is if their Condor is broken, you can fix them yourself by providing your own, and not just providing your own, but sending it along with the job. I don't have time to show that right now, but I want to summarize real quick. In general, the more we're explicit about what we want Condor to do to set up the job environment and tear it down, the better outcomes we'll have. And yes, this is a bit of work to do this translation, but we think the work is worth it. Having said that, I want to be very, very clear that this is not an all or nothing proposal. There are a lot of cases where it's difficult to translate these parts of wrapper scripts into Condor, or maybe Condor is missing something that you needed. That doesn't mean you should give up. That means that as much as possible, or as much as you have time to implement, moving functionality into Condor from wrapper scripts benefits everyone. And the real question I have, and the real reason I want to give this talk, is we know from that previous slide that we're missing some functionality in Condor that helps you avoid the evils of wrapper scripts. Please help us understand what they are, how important they are to you, and how we should prioritize fixing these things so we can make high throughput computing better for everyone. With that, I want to thank everyone for paying attention, and I think we have a little bit of time for questions.